could be very high pressure too.
Yeah.
410 is a very high pressure system. So type 1 and type 2 are kind of the same there. For leak detection after the installation of any type of system, the unit should first be pressurized with nitrogen and leak checked in order to determine the general area of a leak. Use an electronic or ultrasonic leak detector. Once the general area of the leak has been located, use soap bubbles to pinpoint the leak. They're still, there you go, they're still pushing soap bubbles.
Yes.
Just because they're really the most accurate. They show exactly where it's at. Leak repair requirements. Here's where it kind of changes. EPA requirements require that all comfort cooling appliances containing more than 50 pounds of refrigerant must be repaired if the annual leak rate exceeds 15%. So you gotta determine whether find the leak or whatever, determine that it's leaking. If it's got more than 50 pounds of refrigerant from the nameplate, says it holds 125 pounds of refrigerant, and you put your gauges on there, and you've only got 50 psi, you'd be pretty sure that most of that refrigerant's gone. You're going to have to fix that leak. If it's just a little bit low, you don't have to fix it. But best common practice is to find them and fix them. The customer may not be as happy with you once you get your bill, but he'd be happier if you come back next week and putting more refrigerant in it. 2 weeks later, putting more refrigerant in. He'd rather just fix it once, get it done. EPA requires that all commercial and industrial refrigeration containing more than 50 pounds of refrigerant must be repaired when the annual leak rate exceeds 35%. So if you got...
Really, it's that high? I didn't think it was that high.
For commercial and industrial.
Yeah. I mean, in buildings like I was doing,
Yep.
I'm surprised.
35%.
That's a lot.
That's a lot of refrigerant.
Yeah.
But if it's
especially
not,
when you have several, at least 50 or more units in a building, main units.
Yeah.
Wow.
Yep. Good. That's the latest requirements from the EPA right now. So that's kind of what we go by. Recovery techniques. The proper recovery techniques begin with the use of appropriate recovery equipment that has been certified by an EPA-approved laboratory to meet or exceed ARI standards 740. ARI is just an air conditioning institute that checks the equipment and gives them a certification and a number. Yep, 740 is the number. Recovered refrigerant may contain acids, moisture, and oil. It is therefore necessary to frequently check and change both the oil and the filter of the recovery machine. Both recycling and recovery equipment use hermetic compressors, which have the potential to overheat when drawing a deep vacuum, because these units rely on the flow of the refrigerant through the compressor for cooling. Before using recovery, you should always check the service valve positions, the oil level of the recovery unit, and evacuate and recover any remaining refrigerant from the unit's reservoir. You gotta make sure on your recovery equipment that your fan on there is working really good, because it's basically that type of compressor right there that they're using in those things. And in an air conditioning system, the cool refrigerant coming back, falling over the motor, cools it down. This one here, once it gets down to where there's no refrigerant, it's just struggling to pull the last little bit of vapor out. There's nothing falling on that compressor to keep it cool. So you can burn them up. Make sure your fans are working good and keep the thing cool. Technicians working with multiple refrigerants before recovering or recycling a different refrigerant must purge the recovered recycle equipment by recovering as much of the first refrigerant as possible. Change the filter and evacuate. The only exception of the rule is for technicians working with 134A who must have a special set of hoses, gauges, a vacuum pump, recovering recycling machine, and oil containers for use with 134A only. We're not gonna be dealing with 134A. 134A is mainly in cars, and that's a different ARI standard of
You'll see
certification.
Like water, fountains and stuff like that.
Yeah, and typically, they do have a whole different type of connection for
Yeah,
the
it's larger.
hoses. It's a bigger connection, so you got your own setup of equipment for those. Although recovering refrigerant in a vapor phase will minimize the loss of oil, recovering as much as possible in the liquid phase can reduce recovery time. Anytime you can put a tank onto a system and pull liquid out of it without the assistance of a recovery machine, do it. Just makes it that much quicker. You know, if the compressor's working and if you can put a machine on the discharge side of the system and let that compressor pump it out off through the condenser as a liquid, draw it all out as best you can. You're gonna get oil and stuff mixed in with it, but it just gets done a whole lot quicker. When performing refrigerant system service on a unit that has a recovered storage tank, refrigerant should be placed in the receiver. Refrigerant should be removed from the condenser outlet of the condenser. Refrigerant should be removed from the condenser outlet if the condenser is below the receiver. That was my class yesterday. It's kind of getting confusing here. We was talking, in my other class, we were talking about some systems we have down there. If your condenser, or if your condenser is below your evaporator, so your evaporator's up here and your condenser's here, you want to remove from the condenser. If it's just the opposite, if your compressor is setting up on the roof and your condenser is down below, you want to remove from the condenser or from the evaporator down below. Just because the refrigerant will migrate down through, especially if it's hot up there and nice and cool down here. That refrigerant will migrate down to a cool spot and turn to a liquid and just sit there. If you're trying to remove from up on the roof and turn that liquid down here to a vapor and draw it all the way back up out, it'll take you forever to do it. You can just put a tap valve on it and drain it as a liquid into a tank. It'll drain
Like my
down the
house,
road.
you're saying that's down low in the basement.
Yep.
It'd be better to go down there and tap it somewhere there.
Tap it from the evaporator down in the basement, yeah, if your condenser's set up at ground level. Or if you got a house where condenser's on the ground and the evaporator's up in the attic. And you draw from down below. You always draw from your lowest point. Recovery requirements, already did that. Here's some different things now where you gotta remember before 93 and after 93, which is different than type 1. Type 1 was 80% of the refrigerant before 93, 90% after 93, based on whether the compressor's running or not. 80% if it's not running, 90% if it does run. This one here, HCFC 22 appliances or isolated components of such appliances normally containing less than 200 pounds of refrigerant. Equipment manufacturer dates before 1993, just had to pull that down to 0. You don't have to get it down to any inches of mercury, anything like that. After 93 is 0, so you're good there. HCFC 22 appliances containing more than 200 pounds of refrigerant. Before 93, you had to pull it down to 4 inches of mercury. after 93 equipment, it's gonna pull down to 10 inches of mercury. Other high pressure appliances containing less than 200 pounds of refrigerant, again, you're at 4 and 10. Yep. And then high appliances containing more than 200 pounds of refrigerant. Before 93, you're at 4 inches. After 93, now it's at 15 inches. So you got to remember, if it's R22, less than 200 pounds or more than 200 pounds, that's where it changes. And then if it's high pressure, less than 200 pounds or more than 200 pounds, that's where it changes there from 10 to 15. It's kind of 4 inches across the board, except for the first one of 22, less than 200 pounds, that's 0.
I think it wouldn't matter all the way across the board, it should be the same.
It should be.
I don't understand it.
It's the EPA and this is their guidelines, is what they expect. It would be a whole lot easier just to say,
All the same.
pull it all down to 15 inches of mercury on every piece of equipment you work on,
Yeah.
and everybody's gonna know that.
Exactly.
That's not our government.
They don't make nothing.
They don't make anything easy, yep. And very high appliances, very high pressure appliances, which is a 410 system, very high pressure. He said he's never had that question, but someone's told him that it's been on the test, that this has been there. And it's just 0 and 0. So it doesn't matter, you just gotta pull it down to 0 inches. But you gotta be careful, even though you put your recovery machine onto it and you pull it down, and if you look at it and you watch it and it gets right to 0, you turn it off, you can't just automatically start cutting lines, because there's still residual refrigerant in there. You really should let it pull down to the 10 inches below and let itself shut off, and then let it build the pressure back up, come back on, to where you know that you're good at 0, there's no refrigerant left in it. It says right here, after reaching the desired vacuum, the technician should wait a few minutes to see if the system pressure rises, indicate there's still refrigerant in liquid form or in the oil. Appliances can be evacuated to atmospheric pressure, 0 degrees, if leaks make evacuation to the prescribed level unobtainable. So if you know there's a leak in the system, and you can pull it down to 5, or you pull it down to 0, or a little bit below. If you're looking to get down to 10, you can get it down to about 5 inches below, and it just won't go anymore. And as soon as you take your gauges off, or as soon as you take your pump off, it goes back to 0. You know that there's a leak in there that you just can't pull that vacuum, so you're good with it. As long as there's a leak that won't allow you to pull what they're looking for, you don't have to. You just pull it to 0. The technician must isolate a parallel compressor system in order to recover refrigerant. Failure to isolate a parallel system will cause an open equalization connection and will prevent refrigerant recovery. Parallel systems, what they're talking, if you got 2 compressors side by side, you isolate one, pull as much as you can, and then pull from this one. If you're trying to do with both connected, it can just do a loop in there, and you're not gonna get a whole lot from out here. It'll eventually pull it out, but it's gonna be harder to get it. System-dependent recovery equipment cannot be used on appliances containing more than 15 pounds of refrigerant. So you can't use that to do your complete recovery. You can do system-dependent if the compressor is running and you can pump some refrigerant out with that compressor running. I don't care if it's got 200 pounds in it. Pump as much of it out as you can, still hook your recovery machine up at the end, and pull your final vacuum with that to get all the refrigerant out. Under EPA regulations, a major repair means any maintenance, service, or repair involving the removal of any of the following components. So if you remove a compressor, a condenser, the evaporator, or an auxiliary heat exchanger, that's considered a major repair. That question is on the test, because they're going to know, want to know what major repairs are. So just remember that it's the compressor, the condenser, the evaporator, or auxiliary heat exchanger. This is kind of where I was when I was talking with some of the other people in here. That it's helpful if you have some knowledge of the HVAC industry, because whether you're doing a major repair or not makes no difference as long as you're recovering the refrigerant out. But the EPA wants to know that you have some knowledge of the industry. They want you to understand what a major repair is.